Okay, lesson 7.2 today will be involving solving equations. We're going to get into that today using addition and subtraction. There are some properties that we will discuss because you're going to have to know those as well. Okay, so we're going to start off easy here with addition and subtraction. Let's, as you're writing that, let's talk about some vocabulary. Okay, because when you get into the algebra world, the word answer kind of goes away. Okay, because I know, at least I think what you're familiar with, oh, the answer in math is, oh, the answer to the problem is, okay, I get that. But in the algebra world, they don't call it an answer, they call it a solution. Okay, why? Because that's, oops. That's the value that makes the equation true. We talked about that the other day, right? True or false, yes or no. Because we can plug in an answer in our equation and it's not true. Okay, so hence why we call it a solution. It keeps it balanced. Remember that the other day with the meter stick? Right? We want to keep it balanced. That's what makes it true. All right, everybody good with that? All right, what does this mean? Given value is a solution. So they will give you an equation, and then they will put a semicolon, and then they will give you their version of a solution. So they're asking you, is 9 a solution of a plus 6 equals 7? Well, I know what, right? We plug this in, so 9 plus 6 is equal to 7. 15 is not equal to 7. How do we represent not equal to in the algebra world? You put a slash through the equal sign. That is correct. Okay, that is an inequality we will get to actually next chapter, but we can introduce it now. Okay, that's how you solve that. So at this juncture right here, there's 1 point, There's 2 points. Okay, and at this point as well, it's a yes or no question. You can write the word no as well. Okay, so those are the easier ones, obviously. I mean, we're not really solving anything. We're just plugging in a value that they give us, a solution that they give us for the variable or for the equation. Right? And again, in my opinion, the only thing that they're really testing you here is do you know what your add, subtract, multiply, divide expressions are? Okay, again, oops. If we plug it in, now what do we got to do here when we plug in the 5? Michael, do you remember? You got to use your parentheses here, right? Don't write 75. Okay. In the algebra world, we're trying to get away from using the x and the raised dot. Okay. In the algebra world, parentheses are more pronounced to use than anything else because there's really no you can't substitute, you can't think of it as anything else other than for multiplication. Okay, so obviously there, if we finish that, 35 is equal to 35, and yes, the given solution works. All right, moving on. No different than this, right? We're going to go kind of quick here because these are pretty easy. Plug in 3. And what do we get on the left here of our equation? Anybody? Michael? All right, we get -2, not minus. We get -2. I'm putting a box around something. I got a question there. Are you not familiar with those that come out negative? Have you worked with negative integers at all? A little bit, not much. That's a question I need an answer to, children. Yes or no, because we got to cover it. Okay. All right. And then obviously, then the last one would be division. And again, they usually separate the solution with a semicolon there. Okay, so they give you the equation on the left, separated by a semicolon. They want you to plug that in. 14 divided by 2 gives me 28. 14 over 2 is 7. That does not equal 28. So the given value is not a solution. All right, I think you can handle those, right? It's pretty easy. Some of you have already done those. Okay. Let's talk about inverse operations. Years ago, they used to teach this in elementary school. I'm not sure that they do that anymore. Where in elementary school, if you were given an addition problem, what they used to say, what undid or what undo, what undoes that operation? That would be subtraction. Addition and subtraction go hand in hand. Okay? They go together. They're inverse operations. If you want to solve an addition problem, you subtract. If you want to solve a subtraction problem, you add.
Please excuse the interruption. At this time, first period students who need pictures in Mastron, Danko, Bailey, and Easter Day. Any student who has those teachers for first period, if you have a picture form or purchased online, please head to the Gold Gym at this time. Mastron, Danko, Bailey, and Easter Day. Thank you.
Okay, so we have something called, and you probably want to write these down, the addition property of equality. Okay, what does this look like in the algebra world? Well, it simply looks like this. Okay, if given a subtraction equation, okay, what you do, remember we got to keep that balanced. Yes, that balance scale, think of that balance, right? Think of this, if you science people, right? Balance scale, that would be the fulcrum. Ooh, fancy word. All right, that's the point where it teeters, yes? That's your equal sign. Okay, listen carefully, because what I'm about to tell you is going to take you through your algebra life. You are always trying to isolate the variable by itself on one side of the equal sign. Did you hear that? You are always trying to isolate, get by itself the variable on one side of the equal sign. Okay? So the variable here is on the left. You agree? Yes? There is also a -4 there. Do you agree? Okay, we have to move that because we want to get the x by itself. Okay, how are we going to do that? If we do this, doesn't that zero out the 4's? Right? And again, I gave you a preview yesterday. What you do on one side, you got to do on the other. Notice how I'm solving these. I'm working down. That's how algebra works. We don't work side to side. We work down the page, down the problem. Okay, so technically over here, we get x plus 0. And on this side, we get 9. Because we added those together, 5 plus 4, right? We're working down the page. Okay, obviously we have an imaginary 1 out here, right? So 1x plus 0 gives us x. And our solution then is 9. So far, so good? Pretty simple, right? Okay, so here's what, in the algebra world, this is what I love about algebra. You need to check it. In the algebra world, you can always check your solution. Okay? And I sincerely mean this. The next quiz that you take over equations, you should know whether you get 100% or not before you even hand it in. Here's why. You're going to check it. If your check comes out to be correct, guess what? You got it right. Right? So how do we check it? Well, we go back to the original equation, which was, oops, come on, there we go. X minus 4 plus 5. We came up with our solution was 9. So we plug in 9 where our solution goes, and we solve. And this is what we're talking about. Do you have a balanced scale? Is it the same on both sides? Well, guess what? You just got the problem right. Okay, so look what's on the board there. That is what is expected of you. This is why you're going to need paper. Okay, so here we go. This is in the red is the original equation, right? Okay, so here's 1 point for doing the addition property of equality. There's 2 points. There's 3 points. There's 4 points. There's 5 points for that simple problem. So now you get to pick and choose what you don't want to do. Okay, you obviously don't get a point for the original equation. Okay, but you get a point for all your other work that you do. Okay, so you do one of the 5. Hey, Mr. Fisher, I know the answer is 9. Fantastic. You just got 20% out of 100. 1 out of 5. Not a good percentage. Okay, so far so good. Yes? All right, let's try the subtraction property of equality. This is where you got to kind of just flip your brain a little bit and look at the equation, and you're actually doing the opposite, the inverse operation to solve it. Okay, so we'll stay with the same one. We'll just change the operation to make it easy. So there's the original one. Again, we want to keep or get the variable by itself on one side of the equation. Okay, yes, these are extremely easy. Yes, I know you can do them in your head. I get all that. But you don't know what's coming down the road. That's why I'm trying to help you here. Okay, so now we subtract. Why do we subtract? Because we have we have an addition equation. We do the inverse operation of it. We do the opposite. What you do on one side, you got to do on the other. Okay, now we solve. I hesitated to ask you last problem, but I guess I'll ask you now. Well, nobody asked. Mr. Fisher, why do we got to do this? What's the purpose of this? Yes, I can see that X and the 4s cancel out. Anybody have any idea? What's in the black dotted box is a mathematical property. Chase, do you remember? Okay, there is technically no property of 0, but the identity property of 0? Okay, that is a property. Okay, from there, yes, obviously x, and again, there's an imaginary 1 out there, so it really is 1 plus 0. Okay, which gives us x, and obviously then that gives us our solution of 1. And again, as I've always said, as I just said, well, I know, Mr. Fisher, I can do this in my head. I can do it quicker. I can do all that. Okay, that's fine. If you can do it that easy in your head, then my response is write it down if it's that easy. Because again, I'll give you a little preview what is coming. These steps are going to be getting a lot longer. The problems, the equations are going to get a lot harder. And if you don't know how to do the really easy ones, that's where you're going to begin with the hard ones. You're not going to be able to do them. So I'm just giving you a heads up. All right, so we have x plus 4 is equal to 5. That was the original equation. Our check, we take our solution. Obviously, we plug it in. And again, we get 5 is equal to 5. And our balance scale is balanced. So we're in great shape. Okay. Everybody good? Okay. What happens if we get one that looks like this? What's different from this than the other two? Other than the numbers are different. I get it. Ready? Okay, so, oh my gosh, things have moved. Oh no. The variable's on the right. I think as Brady said, the equation is on the left, which is fine. Okay, things are going to move. They're not going to be nice and pretty every single time. That's not how algebra works. But as long as you go with the operations that you have been taught, you are going to be in good shape. Okay, so the first thing you want to identify, what kind of an equation do you have? And how do you identify what kind of an equation you have? You look at the operation. Michael, what do we got? All right, we got a subtraction equation. This is where you got to flip your brain here. We have a subtraction equation, which means we are going to add. We are going to do addition. What are we going to add to both sides? Awesome. We are going to add 7 to both sides. That is absolutely correct, sir. Notice again how I'm working down the page. I'm not working side by side. Algebra is a nice, neat concept if done correctly. Okay, so over here on the left, I can put my equal sign in, obviously, so we get x plus 0. And again, right now, this step, I'll be honest with you, is kind of meaningless, but it's going to be important as we go forward. Okay, and over here, we then obviously get 25. 25 is equal to x. So our solution here is 25. Well, let's check it to see if we're right. Am I going to have to do the check? Yes, you're going to have to do the check. Listen, I don't, from a math teacher's perspective, from a common sense perspective, why would you not want to know if you're right? I don't know. Because if you got it wrong, now you have a chance to go make it right and get the points. Okay? So we have 18 is equal to x minus 7. We did say that our solution was 25. 18 is equal to, that would be 18. And we are balanced. So that means we got it right. Our solution is correct. So far, so good. Okay. We'll do one more. $26 is equal to 11 plus x. Okay, first identify what kind of an equation do you have? Michael? Okay, in addition one, locate the variable. Variable is on the right again. Okay, we want to get that, isolate the x by itself, which means then we got to move the number that is on that side. What are we going to do? Chase? All right, we're going to subtract 11. What you do on one side, you got to do on the other. X plus 0, 26 minus 11 is 15. 15 is equal to x. That is our solution. We go to check it. 26 was equal to 11. Oops. 11 plus x. We said that our solution was 15 plus 11. 26 is equal to 26. All right, everybody good with those? You understand the process of working down to solve them? Okay, listen, as I've always said to you, I'm gonna be honest. If you're not working down, and this is one of those things where if it doesn't look like this, because I've given you a whole bunch of leeway to solve problems, but in the algebra world, there's really only one way here, children. They've got to look like that on your paper. All right. What if we got something that looks like this? Oops. Now what? Uh-oh. Well, what's different than the other equations that we have been doing? Michael? Okay, there's 3 numbers this time. Uh-oh. Again, we start off easy and then we move towards harder problems. Okay, do we move the 7 and the 12 at the same time? No, we do. What do we do, Brady? No. No. Good guess. No, that's a good guess. Chase. Yeah, what is that called that you learned? No. No. Listen, you can make light of it, but this is going to be on the air test because this is one of those terms that they love. And it's obvious that you don't remember. This was way back in chapter 1 again. Grayson, do you remember, buddy? No. You have like terms. Remember when we talked about coefficients, constants, terms, variables? We combined like terms. Remember that? Some of you do, some of you don't. Well, again, they're coming back. Okay, so you want to, again, what do we always say? We want to simplify things as far as we can until we can't do it anymore, and then we can start the process. Okay, so now we have to do one step before we get our equation here. Right? I mean, there's so many ways, different ways that we can present an equation before you even begin solving it. It's kind of ridiculous. But you've got to recognize what you need to do to put it into equation form.
Students, please excuse the interruption. At this time, students who have first period, Mr. Fisher, Mr. Studer, Kepler, Kerr, or Davide, please head to the Gold Gym if you have a picture form or purchased online pictures. Fisher, Studer, Kepler, Kerr, and Davide. Thank you.
All right, so what kind of an equation do we have here? Addition. I guess Michael's the only one participating today. Okay, which means that we have to do the opposite, which is subtract. Y plus 0 is equal to 11. Y is equal to 11. Our solution here is 11 for Y. So far, so good? Okay, we're going to check it. We get Y plus 7 plus 12 is equal to 30. Our solution was 11, so I'm going to plug in 11 there. Eleven plus 7 is 18. 18 plus 12 is 30 is equal to 30. Problem solved. All right. Now we've done equations with only whole numbers here. Can you do them with decimals? Sure you can. And we can also do them with fractions. Oh, it's getting good now. Here comes chapter 4 into play. Hopefully you're realizing what you've already been taught is coming back. All right. When it comes to fractions, okay, and this is really the only exception that I can think of. Okay, when it comes to fractions, in the algebra world, you know how I talked about you work down the page? Okay, well, no, fractions, it's a little bit easier if you go side by side. Okay, and I'm okay with that here. Because once you start stacking fractions, it gets ugly. Okay, so again, first thing you're going to do, you want to isolate the variable by itself. and then identify what kind of operation or what kind of an equation we have. So we are going to add fractions. Uh-oh. We are going to add fractions. But yet, in the meantime, we're solving the equation. All right. So on the left, we get j plus 0, correct? A negative a half plus a positive a half is a 0. Okay, this is why I asked you or told you side by side is a little bit better for fractions. Well, can we add those? Can we add them? Okay, what do we get? On the left side of the equation, what do we get? Okay, in order to get that, though, didn't you have to find a common denominator? That brings you back to your elementary days. In order to add fractions, don't you have to find a common denominator? When you subtract fractions, don't you have to find a common denominator? Yeah, see, these are the things that they expect you to know. So now we get 2 fourths plus 3 fourths, and Michael is right. We now get 5 fourths is equal to j, or 1 1/4. Okay, now here's what I will tell you when it comes to fractions. It's easier to check them if you leave it in improper fraction form. However, the answer, the solution, may be in mixed number form. I wish I could give you a better reason than that, but I don't. Okay. I'm going to guess on the air test, they're not going to have it as 5 fourths. Okay, because improper fractions don't exist out in the real world. Okay, but in order to check it here, it's easier, in my opinion. 3 fourths is equal to j minus a half. So we have 3 fourths is equal to 5 fourths minus 1/2. Okay. Can we subtract them in their current form? The answer is no. We got to do this. 3 fourths is equal to 5 fourths minus 2 fourths. 3 fourths is equal to 3 fourths. That would be, just so that you're aware, that would be, let's see here, that would be 1, that would be 2, that would be 3, that would be 4 points for your check. Okay, you get a point there for knowing that you have to change the denominator. All right, any questions about inverse operations, adding and subtracting equations? Okay, now if you need any assistance, you have this video, you have all of these examples on today's notes for you to look back at. That is the way that they are expected to be solved. Pretty good? Are you sure? All right. So our homework today then, right? Well, this is due Monday, right? Okay, you have an ed puzzle. No, you don't. Yes, you do. Yes, you do. Sorry. You do have an ed puzzle. You also have a pixel, which some of you already have done. Okay. You have 1 through 33, the odds. Okay, and 37 to 49, the odds. I know that may look like a lot, but again, they're odds. Okay, we got to get practice at this.